This lesson is on the very important topic of common factoring. I don't think I can stress enough how important it is for high school math students to become good at common factoring. And the reason why I put so much importance on it is because it is used over and over again in higher levels of math, and in this course too, to simplify things. And so you really want to become an expert on it so that it won't hold you back in other math that you do later on. So, at its heart, common factoring is the reverse of the distributive law. So we've seen before the distributive law is if we have some number and we multiply it times everything inside the brackets to expand it out. The distributive law involves multiplying, common factoring involves dividing. Okay? So the greatest common factor is the largest number or term, because it could be numbers and variables and even exponents, that divides into each term of a polynomial. So each term, that part's important as well. But it has to be the largest. And if we do that, if we find the greatest common factor, then that's what we're going to divide everything by, and that's how we begin with common factoring. So the common factor we find, and we call it GCF, greatest common factor, we're going to call GCF for short, especially when we're writing it because it's a lot quicker. So to common factor, we find the GCF, and then we put any remainder from the division into a bracket. So the first example here is not common factoring, it's just finding the GCF. And this is kind of, to be honest, kind of a funny way to look at it. I don't generally think this way, but it is one way that could be helpful to us. So I'll show you these examples, but I have to admit I don't generally, after showing you these, don't use it myself. We can think of 8 as 2 times 2 times 2, right? So I'm looking at, when looking at this here, 8 is equal to 2 times 2 times here. The dots just mean multiply. We know that 12 is the same as 2 times 2 times 3. 2 times 2 is 4, times 3 again is 12. So what this example is trying to show us is that if we find the parts that are the same, we got a 2 in each of them, we actually got 2 2's in each of them that are the same, that's the common part. You'll notice that what I didn't put the box around was a third 2 from the 8 and a 3 from the 12. So that's not part of my common factor. So if I wanted to take a common factor out of 8 and 12, 2 times 2 equals 4, right? So 4 would be my greatest common factor of 8 and 12. In other words, it's the biggest number that goes into both 8 and 12, and we know that. If you look at 8, we know that we can divide that by 4, and we know we can divide 12 by 4, and it's the biggest number, let's say, that goes into both of them. 14 and 21 can be written as 2 times 7 and 3 times 7 respectively. So again, this is the part that's common to each of them. So I can take a 7 out of each one of these. So in number 3 here, it hasn't been broken down for us. So since we're on the roll here, let's do that. So 5x squared can be thought of as 5 times x times another x, because x squared just means x times x. 10x can be broken down as 2 times 5 times x. So I didn't line them up nicely like I did before. I guess I could still sort of circle things though. So I could match up one x from each one of these, and I can match up the 2 5's, one from each of these. Those are the parts that I can pick out from each one. So from that, I know that the greatest common factor, the biggest thing that I could take out of 5x squared and 10x, is a 5x. So I identified that one. Oh, there's one more, sorry. Let's see. So 6 That's a G, isn't it? 6a squared b cubed could be broken down as 2 times 3 times a times a, that's my a squared, times b times b times b. B cubed means 3 b's. 21 a cubed b squared could be broken down as 7 times 3 times a times a times a times b times b. So if we figure out what's the same in both of these, we got this 3 and 2 of the a's match up for each of these, and 2 of the b's also match up. So if I was to take all of that, then the greatest common factor would be 3, and then 2 a's, a times a is a squared, and 2 b's would be b squared. So I'm reading, even though I've put a box around both lines, I'm really just reading one line or the other. So 3AA and, I want to highlight everything they're doing. 3AA and BB gives me the 3A squared B squared. Just like I'm only reading one line on this one, 5x gives me the 5x. So I match them up from each of them, but I'm only taking it from one line. So that's how I can think about common factoring. Again, early at the beginning I said I don't write this out. And it's true. I do this in my head normally, just from, when you practice it a bit, you get to the point where you don't need to look at it. There's a couple rules of thumb you can look at. So let's actually talk about that for a second. If I look at the 6 and the 21, I can just think, well, what's the biggest number that goes into both 6 and 21? Well, that's the 3, right? I didn't have to write it out. I can just think, what's the biggest number that goes into 6 and 21? It's the 3. If I look at the a squared and the a cubed, when I think about dividing, a cubed, as we've seen, means 3 a's. A squared means 2 a's. The biggest thing that I can divide into both of those is always going to be whatever the smallest one is. So in other words, I just identify what the smallest exponent is on any of the variables. In this case, it was the squared, and that's the squared on the a squared there. And that turned it green on me, so that's confusing. Anyway, as far as the b's go, b cubed and b squared, again, take the smaller one, go for the b squared. That's why we've got b squared there. Let's see what color this makes. Turned it red. Interesting. Hopefully you understand, though. Common factor of the following. Okay, so now we're going to put it all together. The first step is to get the GCF in the same way we just talked about. But I'm not going to write it all out this time, so I'm just going to explain my thinking. So I'm going to look at the numbers. So I'm going to look at 3 and 12 and think, what's the biggest number that goes into 3 and 12? And the answer is 3. That's my GCF. Okay? Well, that is my GCF, but I should consider the x's as well. The thing is, I've only got this x here, but there's no x beside the 12, so I can't take a common factor out of something that isn't there. So if there's no x or no anything in one of the terms, that means I can't do anything with it. So the biggest number that goes into, or the biggest thing that goes into 3x and into 12 is 3. That's my GCF. So that's step 1. Step 2 is to divide. So if I divide 3x by 3, 3x divided by 3 is just a single x. If I got 3 x's and I divide that, give an x to each person, 3 different people, each person gets 1 x. So I divide it, and I'm going to put that inside brackets. So I've got x here inside brackets. Then I'm going to go on to the next part, which is the 12, and I'm going to divide that by 3 as well. 12 divided by 3 is 4. And the sign stays the same. So this is what I get. What goes inside the brackets is what I get when I divide by the GCF. This is actually my answer. And if I want to check my answer, I can do the distributive law to expand it back out. I could do 3 times x, which gives me 3x, and I would have to do 3 times 4, which gives me 12. So it can go, we can common factor to break it down, we can do distributive law to expand it back out. So again, just the thinking, doing it part by part. If I do 5 and 10, the biggest number that goes into 5 and 10 is 5. 5 goes into itself and it goes into 10. If I look at the x's, remember the shortcut was to look at the one, just take whatever has the smallest exponent as part of my GCF. And there's no exponent on the x beside the 10, so we'll take that, because remember that's assumed to be a 1. We don't write it down normally, but we assume that's a 1. I won't write it down as part of my GCF because that'll be confusing, but we'll take that one. So we take the smallest one. That's my greatest common factor. Now I go and divide. 5 divided by 5, they cancel out. X squared divided by x, so let me backtrack for a second. 5 divided by 5, so I'm going to divide the two things I circled there. They cancel out, right? When I divide something by itself, this would cancel out. If I divide x squared by x, think about our exponent laws. Remember, that's an x to the 1 again, so I'm going to do x squared divided by x to the 1, which we know is x squared minus x to the 2 minus 1, which is just x to the 1, which is just x. So again, we get faster and better at it with practice, but what I've just shown there is that if I take x squared divided by x, I get x. What we're going to do in every case is we're going to just subtract the exponents. So x squared, x to the 2 minus 1 is just x to the 1, or just x. Then I go on to the next part, and if I do 10 divided by 5, divide those two things I just circled, 10 divided by 5 is 2. So I'll get plus 2. And if I do x divided by x, they cancel each other out, so there's no x's left. So this is my final answer here for common factoring. 5x on the outside, x plus 2 in the middle, not the middle, in the middle of the brackets. And I could check that by expanding out. There's 2 more examples, as you can see. I'm going to just erase this because it's sort of in the way of example 4. But there's 2 more examples, and I'm going to do the same thing for each one of them. They certainly look harder as I go along, but I'm not going to do anything different. So if I look at the numbers and look at 14 and 21, then the biggest number that goes into both of them is 7. And then if I move on to my a's, I've got an a squared and a to the 3. Remember, I'll always just take the smaller exponent. So I'll take the a squared as part of my GCF. And now I've got b's as well. I've got a b and a b squared. I'll take the smaller one, which is just b. It's assumed to be b to the 1. That's my GCF, just color-coded by parts. Then I'll go 14 divided by 7. That equals 2. Then I'll do a squared divided by a squared. That cancels out, so I'm not going to write any a's down. Then I'll do b divided by b. Those also cancel out. So it turns out the only thing I'm going to have inside the brackets for the first part is the 2. But then I move on to the next part, and I'm going to divide negative 21 by 7, and that'll give me negative 3. And then I'm going to divide a to the 3 by a squared. And if I subtract the exponents, if I do exponent 3 minus 2, I get 1. So I'll have a to the 1, or just a. And then I'm going to divide b squared by b. So again, if I subtract the exponents, 2 minus 1 is 1, and I don't need to write the exponent down, so it would be 3ab. So I've got my GCF on the outside. I've got the remainder, after I've done the division, on the inside. Last example looks complicated, but it's exactly the same approach as long as we keep our wits about us. So looking at the numbers, I got negative 6, positive 21, negative 9. A rule of thumb that we usually follow when we're common factoring is whatever the first number is, if it's positive, we make our GCF positive. If our first number is negative, we'll take out a negative. So in other words, since this is a negative 6, I'm going to take out a negative number here. So I'm going to make it negative, and I'm going to look for the biggest number that goes into 6, 21, and 9, and that would be 3. So I'm going to make it a negative 3 as part of my GCF. I've got c to the 4, c to the 2, c to the 3. I take the smallest exponent, which is c to the 2. I've got d to the 6, d to the 4, d to the 2. I take the smallest exponent, which is d to the 2. That's my GCF. That's what I'm going to divide everything by. Negative 6 divided by negative 3 is positive 2. C to the 4 divided by c squared, subtract the exponents, and I get c to the 2. D to the 6 divided by d to the 2, subtract the exponents, and I get d to the 4. That's the first term inside the brackets. Then I move on to the next term and do it again. 21 divided by negative 3 is negative 7. C to the 2 divided by c to the 2 cancels out. No c's there. D to the 4 divided by d to the 2, subtract 2 from 4, and I get d to the 2. Move on to the last one. Negative 9 divided by negative 3. Two negatives make a positive when I divide, so it becomes plus 3. C to the 3 divided by c to the 2. I subtract 2 from 3, and I get just c to the 1, or just c. D to the 2 divided by d to the 2 cancels out, so I don't write any d's down, and that is my answer. It's longer. It took me longer to do, but I didn't use any different techniques. It's just the exact same technique with more parts to it. So, as a final word, give good attention to common factoring. Very important, and you'll be grateful and thankful later if you do. Good luck.